Hey guys, today I'm gonna show you how to answer the question that says determine the values of x where your graph is increasing or decreasing. Sometimes the examiner will just say determine the values of x whereby your graph is increasing. Sometimes you'll say determine the values of x whereby your graph is decreasing. So it depends. So okay, before I proceed, please guys just subscribe on my YouTube channel so that you can be able to get the notification whenever I upload a video, right? So that you can be able to get notified. Because from me to you, from you to me, this thing is all about collaborating, right? So let's proceed. So in order for you to determine the values of x, in order for you to answer this question correct, in order for you to determine, to be able to answer this question correct, you need to know how to determine the turning points, right? So after determining the turning points, then, or let me say, in order for you to answer this question, you just need to use the x coordinates of the turning points. So let's determine the x coordinates of the turning points so that we can be able to answer this question correct. Yes, so we are going to use our first derivative to find our turning points so that we can be able to answer this question, right? So let's find our first prime so that you can be able to answer this question. The question that says determine the values of x where your graph is increasing. Yes. So let me ask you something before I proceed. Is this an increasing function or a decreasing function? Okay, guys. This is the increasing function. This is an increasing function. Reason being, the value of a, in order for you to decide whether a function is an increasing function or a decreasing function, you just need to check the value of a. If the value of a is positive, like for instance, the value of a here, the value of a is equal to positive 1, right? The value of a. Remember, we have a, b, c, and d, right? So the value of a is positive, meaning that we have an increasing function, which means our graph is going to start by increasing before it can decrease, right? It's increasing, then here is it's increasing, but here is decreasing. Then from this point to this point to this point, it's increasing. So let's answer this question that say, let's answer the question that says determine the values of x whereby your graph is increasing. Our focus is on increasing and also decreasing. Then let's determine our values. Then before we answer this question, you just need to find what? Let's firstly find our turning points. So we have our f of x, which is equal to x cubed minus 3x squared minus x plus 3. Then let's find our first prime, then equate our first prime to 0 so that we can be able to find the turning points. X coordinates of the turning points. In order for you to answer this question correct, you just need to use the x coordinates of the turning points. So we have our f prime. This sign symbolizes what? This sign symbolizes the f prime, which is the first derivative. So we have 3 multiplied by 1, which is 3. Then you put your x, subtract 1 from this exponent. 3 minus 1 is equal to 2. Then 2 multiplied by negative 3 is negative 6. And then you put your x, subtract 1 from this exponent. We have invisible 1. Then 1 multiplied by negative 1 is minus 1. Then let's subtract 1 from this exponent. 1 minus 1 is equal to 0. Anything to the power 0 is equal to 1. So this is just a constant, right? So whenever you derive, you just need to know that you are going to, like automatically your constant is going to become 0. So let's equate our first prime to 0. So we have our is 3x squared minus 6x, then minus 1. Then let's use the quadratic formula because this is a quadratic equation. Let's use the quadratic formula to find the x coordinates of the turning points. Then we have our x, which is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Then our x is equal to minus b. We have a, we have b, we also have c. B is minus 6 plus or minus square root of b. Our b is minus 6 all squared minus 4. Our a is 3. What about c? Our c is negative 1. Then all divided by 2. A our a is equal to 3. Then our x is equal to this, or our x is equal to that. Let me check. Then our x is equal to this, or our x is equal to that. Then our x is equal to 2,15, or our x is equal to negative 0,15. Then now let's use this x coordinates to answer what? To answer this question. So let's draw our graph. In order for you to answer this question correctly, you just need to construct your graph. So we have our graph. This is our graph, guys. This is our graph. We have our x-axis, we also have our y-axis. Then let's construct our graph. This is our graph. This is our graph. We have our TP, we also have our TP. Equal to negative 0,15. But here we have x equal to 2,15. 2,15, right? Now we are going to use these 2 points to determine what? To determine the values of x, whereby our graph is increasing. So let's determine our values of x. Then let's assume that, guys, from this point, as you actually know that a straight line with a positive gradient, as you actually know, guys, a straight line with a positive gradient, meaning a straight line that appears in the first quadrant and also in the third quadrant. Let's draw our straight line, our Cartesian plane. So this straight line appears in the first quadrant and also in the third quadrant, right? So let's assume that this is a cubic graph have been formed by the straight lines, meaning that from this portion to this portion we have our straight line. Then again from this portion to this portion we have our second straight line. From this portion to this portion we have our third straight line, which means this line, the cubic function can be formulated by this, by joining these points, right? So from this point to this point we have a straight line with what? With a positive gradient. The gradient, like the straight line that appears in the first quadrant and also in the third quadrant, right? With a positive gradient, meaning that this function from this point to this point is increasing, right? Which means our graph is increasing, whereby the values of x are less than what? Are less than negative 0,15, right? Or our graph is increasing, whereby the values of x from this point to this point, our straight line, the gradient of our straight line is also increasing, meaning that we have a positive gradient. Even here we have a positive gradient. But from this point to this point we have what? We have a negative gradient. Right? Which means our straight line from this portion to this portion, our cubic function it's decreasing. From this portion to this portion, our cubic function is decreasing. But from this portion to this portion, it's increasing. So it's increasing whereby the values of x are less than what? Are less than, whereby the values of x are less than what? Are less than negative 0.15, or whereby the values of x, or whereby the values of x are greater than 2.15. Right? This is the one, the same thing with whereby the values of x are less than negative 0.15. This and this is one the same thing, guys. You can just write it in this form, right? But there is no any difference between this and this, right? Between this and this. So there is no any difference. So meaning that for decreasing, this is for increasing, right? This is for increasing. Whereby our graph is increasing, right? But for decreasing, whereby the values of x are greater than, whereby the values of x are greater than negative 0.15, but less than what? But less than 2.15. Between these 2 points, these 2 points, our graph is decreasing. As you can see, guys, this straight line is in this form. So our gradient, the gradient of a straight line that appears in the second quadrant and also in the fourth quadrant, we have a negative gradient. Right? So that's how it works, guys. Hopefully you understand everything when it comes to a decreasing and also an increasing function, more especially when you deal with the cubic function.